Welcome students, welcome to my channel. So today I'm going to discuss that how to find the value of correlation coefficient. In my previous video I have discussed what is correlation and what are the types of correlation. You can check it out from the previous video from my channel. So the formula to find the value of correlation coefficient is R. We denote the correlation coefficient by the small letter r. And this is the formula. In the numerator, we have covariance of xy divided by standard deviation of x into standard deviation of y, where this is the formula of covariance of xy, that is equals to 1 by n summation xi minus x bar into yi minus y bar, where xi and yi are the each observation of the variable x and y. X bar and y bar are the average or mean of the respective variables. Small n is the total number of observation we have. Now if we simplify this, we will get n summation xy minus summation x into summation y. This is the formula of standard deviation of x and this is the formula of standard deviation of y. As we all know that these are the formulas of standard deviations. So on simplifying the formulas, we got the second formula here. These are the simplified formula. And also one more thing here, that the correlation coefficient is also known as Karl Pearson's correlation coefficient. Now, this correlation coefficient has a specific range. It does not lie beyond the range -1 to +1. It always lies within this range. Here I have given you a chart from where you can get a clear idea that what is the level of correlation on the basis of the value of R. So from this table, we can see that when the value of R is near about 1 plus 1, we are saying that the level is very strong positive. And when it is near about minus 1, then we are saying that the level of correlation is very strong negative. That means there is a strong negative correlation between them. That means when one variable increases, other strongly decrease, and in the case of very strong positive, both the variables are increasing or decreasing together. And one more thing here we have to notice, that when it is near about 0, then we are saying it is either very weak positive or very weak negative, and very weak positive or very weak negative. So, in simple word, when the value of R is +1, that means there is perfect positive linear relationship, and it gradually decreases when the value of R goes towards 0. When it is the value of R is -1, that means there are perfect negative correlation between the variables, and it gradually decreases or gradually, gradually decreases towards 0. And when the value of R is exactly 0, that indicates that there is no correlation between the two variables. So I think this is clear now, that what is the level of correlation, how to interpret the level of correlation on the value of R. Next we have an example, and here we will discuss that how we have to find the correlation coefficient when we have a data. This is a very simple data here, so that you can get a clear idea on that. Now this is the working formula we have to use. In this table, we have found out all the necessary information. Like here we have in the formula we have x square. In the third column, we can see that we have calculated the values of x square, that is 1 square 1, 2 square 4, 3 square 9, and so on. In the fourth column, we have calculated y square, as we also require the value of y square. And in the last column, we have calculated x into y, as we also require summation xy. And in the last row, we have calculated the total of all the values of that respective columns. Now, what is n here? N is nothing but the total observation we have. What is the value of n? In our case, it is 6. If we look into this data, then we can see that we have only 6 observation per variable. So n is 6 for our data. So here we have put all the information we got from the previous table, and calculating the formula, we got the value of r, that is 0.8607. So what is the correlation coefficient of our data? It is 0.8607. Now what is the interpretation? Let's go to the table of the range. So if we look into this table, we can see that the value of r, which we have calculated, lies on the first row, lies here in the first row. That means there is very strong positive correlation between the variable x and y, that is, as our observed r is 0.8607, it is very near to 1 plus 1. That means there is very strong positive correlation between the variable x and y. So I think now you have a clear idea that how to find the value of the correlation coefficient when you are given data. I think you have a clear idea now. So here I have given you another problem. You can try this by your own. Here you have to calculate the correlation coefficient just like I have shown you right just now, and also interpret the strength and direction of the relationship. Strength means that how much, what is a level of correlation between them, and direction means whether the variables are positively related or negatively related. So these are the meanings of the interpretation of the strength and the direction of the relationship. I've also given you the answer, final answer, so that you can check whether your calculation is correct or wrong. This is 0.9947. This would be your answer. So this is for today. I think this video is helpful for you. If you like this video, please like, comment and subscribe my channel. See you in the next one. Thank you.